Inside a quiet office in Hangzhou, a small team posts a file to the internet. No press release, no event, just a file. It is called R1, and it is completely free. The date is January 20th, 2025. For 6 days, almost nothing happens. Then, on January 26th, the app begins climbing the US App Store charts. By nightfall, it is #1. It has just surpassed ChatGPT. Within hours, it holds that position in 51 countries. The next morning, US markets open. Nvidia, the most valuable semiconductor company on Earth, starts falling. By midday, it is down 12%. By close, it is down 17%. $589 billion in market capitalization erased in a single session. The largest single-day market cap loss in American stock market history. Bigger than any bank run, steeper than any financial crisis. Mark Andreessen is a billionaire venture capitalist who had bet heavily on American AI supremacy. He tweets 5 words: DeepSeek R1 is AI's Sputnik moment. The company behind R1 has 140 employees. It is backed by a hedge fund most people had never heard of. It built the model on computer chips the US government specifically banned from sale to China. This is the story of how that happened. His name is Liang Wenfeng. Most people in the West had never heard of him. No Silicon Valley background, no government backing, no famous company on his resume. Just a hedge fund manager from Guangdong province with a degree in electronic engineering from Zhejiang University. In 2015, he co-founded a quantitative trading firm called High Flyer. High Flyer used machine learning to read markets and execute trades faster than any human could. By 2021, the firm was managing approximately $14 billion in assets. But Liang was watching something else. He believed the next wave of AI would not just move markets, it would reshape everything. So he started buying Nvidia A100 GPUs, not for trading, for research. Quietly, High Flyer assembled one of the largest private GPU clusters in China, roughly 10,000 A100 chips, all acquired before any export restrictions existed. Here is the part most people miss. DeepSeek has never taken a dollar of outside investment. High Flyer's trading profits fund it entirely. The models are free, no subscription, no plan to go public, no monetization strategy at all. Liang said it plainly, most Chinese companies are used to following rather than innovating. He built DeepSeek to break that habit, not to make money, but to prove something. Then, in October 2022, Washington made a move specifically designed to stop him. However, it did not stop him. It transformed him. On October 7, 2022, the US Department of Commerce issued sweeping export controls. The target: advanced semiconductors heading to China. The centerpiece was the Nvidia H100, at that point the most powerful AI training chip on the market. Washington's logic was clean. No advanced chips, no advanced AI. But Nvidia had a response. They built the H800, a version of the H100 modified specifically to comply with the new rules. Same processing cores, same raw power, but one critical component was reduced. The NVLink interconnect, the system that allows chips to communicate during training, was throttled to half its original bandwidth. This mattered more than it sounds. Training a large AI model does not happen on a single chip. It happens on thousands of chips, all passing data to each other in real time. The US had not banned a chip. It had cut the nerves between the chips. Here is the part nobody talks about. The H800 itself was a product of the first export ban. Washington restricted one chip. Nvidia built a workaround. China bought the workaround legally, and Liang Wenfeng purchased 2,048 H800s before a second ban closed that gap in October 2023. He now had a cluster capable of serious training runs, but it was crippled in exactly the dimension frontier models demand most, which was communication speed between GPUs. OpenAI had $10 billion from Microsoft. Google had custom hardware. Liang had 2,048 handicapped chips and 140 engineers. Nobody anticipated what they would do with them. The big problem was bandwidth. Every time DeepSeek's GPUs needed to sync during training, they hit a bottleneck. The throttled NVLink connection was a wall they could not remove, so they went around it. The H800 chip has 132 compute cores. Each core runs calculations. DeepSeek's engineers reprogrammed 20 of those cores to stop doing math. Instead, they became communication routers, managing data flow between chips more efficiently. They sacrificed processing power to fix the bottleneck the export ban had created. That was only the first move. The second problem was size. Standard large language models are expensive because they activate every parameter for every output. DeepSeek built something different, a mixture of experts model. Think of it like a hospital. A general hospital routes every patient through every department, while our specialist hospital sends each patient only to the doctors they actually need. DeepSeek R1 has 671 billion parameters total. For any given task, only 37 billion activate. The rest stay dormant. This was dramatically cheaper to run with no loss in quality. The third innovation was how the model learned. Standard AI training requires a separate AI to grade every output. That grader costs as much to run as the model being trained. DeepSeek used GRPO, Group Relative Policy Optimization. The model generates multiple answers to the same question. It compares them against each other and picks the best. With no separate grader, it led to training costs slashed. Here is the uncomfortable part for Silicon Valley. None of these were desperation hacks. They were better engineering. The well-funded labs had simply never needed to find them. They had enough compute to brute force their way past the problem instead. Scarcity, it turned out, was the better teacher. When DeepSeek released R1, they published something unusual alongside the model, a technical paper with a price tag inside. The final training run for R1 cost $5.576 million. That number landed like a grenade. For context, training GPT-4 was estimated to cost over $100 million. OpenAI has raised more than $40 billion in total funding. DeepSeek's final run cost less than a house in Los Angeles. Now, the full picture is more complicated. That $5.576 million covers the last training run only, not years of research, failed experiments, or infrastructure. Total R&D costs are estimated between $1.3 and $1.6 billion. But even that number is a fraction of what American labs have spent. And unlike those labs, DeepSeek gave the model away. This is where the story gets strange. OpenAI was founded in 2015 as a non-profit. The name said everything. Open, shared, public. Within a few years, it went closed. The most powerful models locked behind a subscription. DeepSeek was built inside a hedge fund. No public mission, no open source mandate. It released everything. The model weights, the architecture, the full training paper. Anyone can download it, anyone can modify it, anyone can build on it. A secretive Chinese quant fund had out-open sourced the company called OpenAI. Wall Street had not processed this yet, but it was about to. On January 27, 2025, US markets opened to a problem. Nvidia was down. Then it kept going down. By midday, it had lost 12%, by close, 17%. $589 billion in market capitalization gone in a single session. The largest single-day loss by any company in American stock market history. Broadcom fell. Oracle fell. Every company tied to AI infrastructure spending took damage. But the sell-off was not really about DeepSeek being better than GPT-4. It was about what DeepSeek implied. The investment thesis for American AI rested on one assumption. Frontier AI requires exponentially growing compute. more data centers, more chips, more Nvidia, forever. That assumption had justified hundreds of billions in spending. DeepSeek suggested the assumption was wrong. A model this capable, $5.576 million to train. What does that mean for the $40 billion OpenAI raised? For the data centers being built right now? Sam Altman called R1 an impressive model and said OpenAI would deliver much better. Mark Andreessen was less measured. 5 words. DeepSeek R1 is AI's Sputnik moment. That comparison was not accidental. Sputnik did not just beat America into space. It forced America to rethink everything it believed about who was winning the race. The question was now the same, and the most uncomfortable answer was still to come. Here is the argument nobody in Washington wants to hear. The chip export controls may have caused exactly what they were designed to prevent. Walk through the chain, the US bans the H100, Nvidia builds the H800 to comply. China buys the H800 legally, the US bans the H800, DeepSeek engineers work around the bandwidth restrictions. That workaround produces the most efficient AI training stack ever built. The restrictions did not slow DeepSeek, they shaped it. And it goes further. DeepSeek is now training its next model, internally called V4, with 1.6 trillion parameters, not on Nvidia chips, on Huawei Ascend processors. China's domestic chip industry was once a footnote. It is now the foundation for frontier AI development inside China. The sanctions were supposed to keep Huawei contained. Instead, they gave Huawei a guaranteed customer, China's own AI labs, with every reason to push the hardware as hard as possible. Liang said it himself. Most Chinese companies are used to following rather than innovating. His point was that this had to stop. The sanctions agreed with him, they removed the option to follow. So, China had to build. The question is no longer whether China can develop frontier AI without American chips. DeepSeek already answered that. The question is, what comes next, when the hardware has no restrictions at all? For 30 years, the assumption was simple. More compute equals better AI. Bigger cluster, bigger model, bigger budget. That was the race. America was winning it. DeepSeek did not beat that race. It changed what the race measures. The new rule is this: the most efficient model wins, not the most expensive one. Efficiency is not a resource you can stockpile. It is a problem you have to solve. The country that restricted hardware may have handed its rival the one advantage money cannot buy: the discipline to build better. Liang Wenfeng's company has 140 employees. It just rewrote what the world believes is possible. The era of brute force AI is not over, but it is no longer the only path forward. And for the first time, someone outside Silicon Valley is deciding where the next path leads. The question is whether anyone there is paying attention. If you enjoyed this video, then please subscribe to the channel. It supports us a ton. See you in the next video.